Well, hi, good morning, and thanks for joining us here in my shop for another day with this radio. That's if my camera continues to operate while the cat chews away on the camera wire. Come on. Oh, I can't do this. This is the sore leg guy. You wouldn't know he's got a sore leg anymore. This leg here is Bobo guy. Oh, this leg. Bobo cat. Okay, down you go. But don't chew my wires. Even though there's quite a broad selection of wires to chew around here. Okay, well, thanks a lot for joining me in my shop here this morning. And going to be doing another run at this radio. I think I'll be doing the capacitor side of things today. And as for the speaker, a couple of ideas are floating around out there. I haven't given up on this speaker. I really haven't pushed to try to get it operating yet. So that'll come. And I don't have a lot of hope about it, but at least I know this radio can serve a purpose even if the speaker is defective. Okay, let's take a look at those capacitors just to remind me of what I'm up against here. So we could, there's not that many in here now because I've already done a couple. So we got this molded guy, the last molded guy, with a big thumbs up. Maybe I'll just leave him there for now. Do this guy. This one, not very, this is the tone control. This is a tone switch, the tone control capacitor there. And again, not terribly important. And two down here, which I'm sure are going to be important. And I have a resistor there that really looks like it's taking a beating. Let me just take a little closer look at that resistor there. Because, you know, it's quite likely I'll be changing a couple of resistors in here. Here we go. So the one I'm looking at is this one here. Well, it doesn't look so bad. Just dirty and hard to see otherwise. But look at the capacitor down below, and then there's another one right up in here. They don't look so good. Okay, very good. Just pondering. It's hardly like this one is not has no consequence. I'll do these two first. Those two are wrapped around the output tube, I think. Is that the output tube there? Yes, it is. So maybe we'll take a peek on the schematic for these two that are just tied right onto the. Oh, I almost stepped on this cat here. Hey, man, come on! What are you eating? There's nothing in here to eat. Spit it out. Come on. What is it? Don't eat the nubbins. Away you go. Goodbye. Oh my gosh. All day long with these guys. What we're going to do, look at the schematic. That's right. Situation here is going downhill rapidly. Now I've got two of them chewing away. Come on, look. You chewed right through. Oh, you're chewing that. Oh, it's all chewed up. It says Wally and Bert. That's Walnut and Filbert. They're their full names. Oh my gosh, look at this guy. Doesn't matter what room you go in our house, there's wires hanging around. I guess that's true in everybody's house these days. Okay. People like seeing my cats, so that's why I'm showing them. Okay, let's take a close look at something's not adding up with the schematic. We'll look first in the radio here. So there's two capacitors that are attached to the terminals of the output tube. I've pulled out the output tube. Here it is, 6K6, no question, that's a 6K6 tube socket there. I pulled it out so we could see where the key is, so we can count the pins properly. Now, I certainly have a view of the key here, but something is going wrong. So I think the key is right in here, right in this spot here. That's just got to be the key. So that marks pin number 1 as right under this wire here. 1, this would be 2, and this one would be 3. Pin 3 right here. And if you just look down a bit, there's a capacitor connected to pin 3. Now, the other wire for this capacitor, you're going to have trouble seeing this, but I can see it with my eyeballs from up in this angle here. It may not work on the camera. The lead is coming up to this terminal. You can see that resistor with the mauve end. Oh my God, there was a cat up under my bench. It's going to, well, it's going to terminal number 8. The one just to the left of it there with a wire sticking out of it is terminal number 1, and the key is in between. Is the key in between? Well, I mean, there's no doubt that's the key right there. There's no question. So we have a capacitor hooked between pin number 3 and pin number 8. 3 and 8. Does anybody doubt it? We're going to take a look at the schematic here. Here's the output tube. Let's zoom in a little bit on it. So we can count the pins starting right up here. This is pin number 1. Am I counting them right? 1, 2. Pin 3 is the plate. 4. There's the number 4. 5. 6. That's a G there. 6. 7 and 8. So there should be a capacitor between 8, there's a capacitor here going to ground, and pin 3. I don't see one. I don't see one anywhere. So what? What do you do about that? Why? Well, why would they put a capacitor between the plate and the cathode? Would that be done? I could kind of. I've often seen them between the plate and the screen grid. I've seen that. Is it just like way off in the schematic somewhere? How can it be? It's between this wire here. There's really no place else to connect it but right on this terminal. And that's 3. 1, 2, 3. Well, I'm paralyzed here. I'm mostly paralyzed because if I take a step in any direction, I'm going to step on these guys. Look at them going to town down there. Oh my gosh. He's not chewing the wire, he's chewing this rubber wire holder. Now you're chewing the wire. Look, you've got something better to do, don't you? Don't you have something better to do? You goofy cat, you. Okay, I'm gonna go for coffee. They will no doubt come with me when I do. Maybe they'll leave the shop alone then. Don't tugging on the wires. Help. So I took a look in my one of my favorite books here. What's the story? Oh my gosh, it's almost, no, I was going to say it's almost on the front. So here's a simple diagram, kind of a super simple radio here, output stage. So in this case it's a 6V6, very similar to 6K6. This would be the capacitor that we're talking about, I guess. So the purpose of this capacitor is to take away any high frequency harmonics that have developed in this tube and maybe even in the tube ahead of it. Harmonics are common, and why send them off to the speaker? So what they do is they just drain them out to ground here. Then the high frequencies don't go through the transformer, don't get to the speaker. So that's the basic way of doing it. Putting a capacitor, small one, say 0.005, and And in diagrams here, this reoccurs again and again. The same idea, getting rid of the harmonics, getting rid of the harmonics. Here we are again. Same sort of thing. Now, where to get the ground? So the ground connection is the same as down here, the same as down here. So you could show this wire coming down and attaching here if you wanted. Here's an actual schematic from a radio. This is from an Emerson Model GB. Who knows what that is? So here we can see how it's actually been implemented in a particular radio. If I can just get it in focus there. A little hard to see. There's the capacitor there. The top of it is on the plate circuit. You can see it going to the transformer. And the bottom of it is connected. It's hard for you to see it. Connected to the cathode. And the cathode, of course, is connected to ground, but through a cathode resistor. So here in the actual radio, they've implemented by putting it from the plate to the cathode. Here it is again, shown in a very schematic sort of way. There it is. Here's another radio. Now in this case, there's the capacitor again. In this case, they're using the capacitor to bypass the harmonic high frequencies around the transformer. Same effect, I guess. It's just a slightly different way of doing it. I don't have to say anything. There it is again. So, where do you find the ground? There it is again. It's just on every one of these diagrams. Here's another radio. There's the capacitor again. It's a 0.005 again. So just about every radio has one of these, done in different ways. This one's done across the output transformer primary side. Maybe there's some other reasons for it. I understand the primary reason is getting rid of harmonics. So what's the harm if you let the harmonics come through? I guess a few of them you're going to hear them and they're grating. Maybe it doesn't sound good. Wasting power, unnecessary heating of the output transformer. Who knows? So what do we do with this one? So this one, just to review, is connected between the plate connection, which I'm going to double check all this, and around to pin 8. Pin 8. Let's look in the book. I'll just pick up this 450 million year old rock here I happen to have in my shop. Yeah, with some very early life. Maybe I'll show you that again in a minute. I think I've shown that occasionally on my channel 6. K6. Okay. 6K6. Here we are. So I go pin 1. Oh, pin 1 is not hooked up to anything on this. Pin 1, pin 2, pin 3 is the plate. Pin 8. So pin 8 is the cathode and the suppressor grid tied together internally. And in this radio there is a cathode resistor. Well, I'll show you my rock again. So I picked this up not too far from here, maybe a 20-minute drive from here, a different geological area from exactly where I live. I basically live on a big mound of glacial till. It's kind of what this is. But this is a, listen. Can you hear it ring? It has a ring to it. This is really hard stuff. This is limestone. I think it's called potassium limestone. It has a bluish color to it, and it's really hard and very resistant, especially to chemical erosion, which is rainwater basically. So this rock formed from things that were living 465 million years ago or so, and this rock basically is made up of minerals that have come from the shells of these creatures, and some of them you can see them there. Pretty cool stuff. 450 million years old. So this is the second, what could be considered the second epoch of life, although maybe now it's considered the third, because discoveries are being made in this area all the time. I don't mean this geographical area, I mean in the science area of geology and history of the earth, and that stuff is being found out all the time. So yeah, I think most people in Ontario don't realize the fantastic and exciting geological history that is under our feet, and sometimes literally exposed at the surface, like that rock there. That's exposed at the surface. Hey, look, here's another rock. This one's totally different. This one's a granite. This is from further north. You go just a little ways north, and it's granite, because there never was any ocean water anywhere just north of here. Actually, we live basically at the edge of where ocean was 400 million years ago. We live near. I live near the northern shore of it, if you like. And the reason I have this rock is because of that, because of the mica in it. Because there's mica in there, and there's mica in this rock. That's why. Okay, right? Yeah, I like rocks. What can I say? I've learned to like rocks. Yeah, I'm going to stop and think just a little bit before I do something with that capacitor. So I probably spent 20 minutes studying this little socket here, trying to figure out the capacitors and the like, and I still haven't got a really good feeling. In fact, something rather weird is showing up here. I don't know what to make of it, so I turned on the cameras as to increase the amount, the feeling of embarrassment as I try to sort this out. So we have the capacitor down here, which appears to be connected differently than the schematic. Not connected wrong, just in a different way from the schematic. We have another wax capacitor here. This is the feed to the grid of the output tube, and it's coming via wire from the plate of this tube. So that makes sense. That follows the schematic, and this one makes sense, but it doesn't follow the schematic. But the really weird thing is this thing. So this greenish colored wire is a wire coming out of the power transformer. There's another greenish wire here also coming out and coming over to this tube. There's two wires coming from the power transformer to the output tube. What would that be about? So heaters, the heater power, maybe that's the heater power coming over, so it would attach to the heaters here. Over here it's attaching to, and I'm going to count them again to be absolutely sure, it's attaching to pins 2. Oh, maybe it is the heaters. I think I counted it wrong before. It's 2. I thought it was 3. So we'll just continue on though. 8 and 8 and 7, or 2 and 7. Yeah, those are the heaters, I'm sure. 2 and 7. Might as well look the book open here. 6K6. Yeah, 2 and 7 heaters. Yeah, that's all that is. Okay, got that sorted. And one of them is grounded and being used as a ground terminal, just to add some challenge here. Okay, so that's solved. So what still remains though is this one capacitor hooked up differently than it shows on the schematic, and I cannot convince myself that's not the case. So you might be saying, but Jim, the speaker's blown. Why do you even care about this? Because I hope to fix that speaker. And hope is the word. It's nothing more than hope. But I will take a run at it later. So it makes sense to fix this up. If the speaker can't be fixed and the radio is going to go speakerless, then I would pull out the audio tube and not even have it in there. Just leave it somewhere in the radio, but not plugged in. So this whole circuit would be off. And no use having it run if in the end that's where we end up with a dead speaker. Okay, so we should do a little experiment here, or should we really bother? I would fire up the radio and then take a look at the grid voltage on this tube with this old capacitor there, and then change it and see what happens to the grid voltage. And I've done this a couple of times. I got some results that you would expect and some results you wouldn't expect. Should I do that? I don't think it's too tough to do. It's pretty easy to get the voltmeter on there. Set's all ready to go. Okay. We'll do that. We'll do this experiment. What we're doing is we're looking for voltage leaking from the plate of the previous tube onto the grid of the output tube. through the capacitor I'm about to change. That's the idea. Okay, so we're going to make a measurement. This is kind of like the before and after. It is the before and after. It's not like before and after. Okay, switch on. Now I have no antenna connected. I have no audio output, so we're not going to hear anything. That's fine. We're just interested in the voltage here. Give it a few minutes. Oh, turn on my voltmeter. That's just warming up. Okay, first we'll look for B plus on the capacitor here. There we are. So set is operating. Now we're going to look at the input side of the capacitor, which is which should have some voltage on it. I just don't want to touch the wrong thing here. I'm not seeing a thing here. Let me do the other side of the capacitor. There's nothing on one side. There shouldn't be anything on the other. Nothing at all. Of course, I got this up at 500 volts. Let's put this way down to, well, there should be something like 60 volts on this side. That should throw that meter right over. It's going the other way. It's going the other way. Not going to go the other way. Okay, let's go and find the plate voltage on this tube. This is the detector tube here, first audio tube, and that, I'm going to look it up here. So I've got a little quiet here because things aren't going the way I thought they would. So 6SQ7 is the tube that we're interested in. 6SQ7SJ SLSN. A lot of popular tubes here. 6SQ7. Here we are. So what we would want to do, we want to look at the triode and the plate, which would be at pin 6. We look at the plate voltage. That's the voltage that this capacitor should be seeing. Pin 6. Pin 6. Yeah, okay. Oh, stop the test. Stop the test. Here's the output tube. Oh, doesn't that make any difference in what I was doing? I'm not sure it would, because I'm looking for the plate voltage from the tube before it, but we should have this, yeah, because we're not going to get any plate current without it. There won't be any bias. Maybe that's why the bias was weird in here. Maybe that's what it was. Power on again. That's right, now I was getting ready to find the plate on here, whose number now, of course, I've forgotten. And even if I remembered, I would doubt it. 6. Pin 6. So we're looking for pin 6 on this tube. Pin 6, right. Pin 6. So, okay, there's the key. So that'd be 8, 7. Oh my gosh, 6 is completely. Okay, so I think this is 6 right here. What's going on here? My meter's going backwards again. We're on positive here. And if I touch the how do we get a negative reading here? Because I'm on the wrong thing. It's definitely a negative reading there. Think about it for a minute. Plate is supposed to be the plate. Can't be negative. Can't be negative unless there's something seriously wrong with that part of the circuit. Or am I really booming up here? First of all, is that for sure the 6SQ7? How can I be absolutely sure of that? Because it's not these other tubes. So that's got to be the process of elimination there. 6SQ7. That's definitely the key, and that's definitely 8, 7. Oh, I can see it up here. 6. Pin 6. Yeah, I'm looking at the schematic now, and we want to count these and find the plate. 1. Where's the plate? Plate is way over here. 1, 2, 3, 4, 5. Pin 6. Okay, so everything's matching up. Pin 6 would be the plate. Pin 6. So this is pin 6. This is pin 6. Oh my gosh. How do you get a negative voltage on the plate? Again, this is part of the circuit that's not going to do any good with a dead speaker, but I'm going to continue to pursue this situation. Would the open output transformer cause these kinds of things? I can't imagine it. No, the plate voltage should be there. Where are you plate voltage? So, good question. Like, can we follow the wire? Why? Wait a minute, I must have something wrong here, because this is hooked up to plate voltage. Well, it could be. Yeah, you could be grounding this capacitor on a plate can be a tone control. Grounding that capacitor on a plate. Well, maybe the switch is the problem. Maybe the switch. Maybe I've closed in on a shorted capacitor and grounded that. Which way is this switch? Let's cut the power here. I'm going to sort the switch out. I sort of ignored it up until now because it's just a tone control. Who cares? Well, maybe it's playing a role in the deal here. What I want to do is figure out whether the switch is open or closed the way it is right now. And maybe even a shorted capacitor. So is this closed? So it is. So this capacitor is in the circuit. Is this capacitor shorted right out like a dog? Dog? No, not shorted. Not shorted right out, but we want to open the switch. Is that switch open now? Yes, it is. So this capacitor is doing nothing. Let's see if that. I'm going to just peek at the schematic here very quickly and identify the tone switch. Where are you, tone switch? Here it is, and that capacitor, the tone switch capacitor, is not connected to a tube pin. What is going on here? Okay, hold on a second here. Well, I just discovered I may have made some video errors earlier in the video and not showing the schematic when I thought I was, but can't do anything about that right now. So what I'm curious about here and losing my mind over is the tone control capacitor, or the capacitor that's tied to the switch on the back. So here's the switch. Here's capacitor. 560 picofarads. No, the capacitor's not that size. It's much bigger. And this wire goes to the top of the volume control? I don't think so at all. Oh my gosh. My radio doesn't match this radio. I find too many things wrong here. Where's the Too many things are not working out. What I'm looking for? Canadian General Electric data sheet 59, but what radio is it? What radio? KL500. That's certainly the radio I've got here. Oh, this matches up fine. The tube I'm messing around with is this one, 6SQ7. Has the fancy antenna. RCA, yeah. So this model is the same as an RCA Victor A23. Oddly enough, different manufacturers, same radio. Well, you know, maybe maybe RCA did things a little different than General Electric. And these are some differences, and the schematic's kind of an average of the two or something crazy like that. Oh my gosh. So many things are not adding up quite right, and they don't make sense. That's the other thing. They don't make sense. It's probably me. That's usually what I end up concluding and discovering. It's just me. I'm just not seeing things the right way here. So, am I wrong about the tone switch? I can't be wrong. I mean, the switch is the switch, and it does go to ground. But this is not a 560, and it's hooked up. Where is it connected? So it's connected to. Oh my gosh! Just bear with me a second here. Pin number. Okay, pin number 7. Pin number 6. Pin number 6 of this tube. Pin number 6 of 1, 2, 3, 4, 5, 6. Screen grid. Okay, if this is attached to the screen grid, then it's a silencer, I think. Screen grid? No, I don't know that would. If you broke the connection to the screen grid, that might silence the tube. Any capacitors on here? This one, 0.05. This is the guy. No, that doesn't make sense, because there's a switch. This is the one that switched. Oh my gosh. You know what? I'm gonna get my copy of the A23 schematic out. We'll take a look at that. I'm heading down the rabbit hole. So the one we've been looking at is this one, KL500, and the same as RCA Victor A23. Well, here's the RCA Victor A23. How do I know it's the A23? Let's just be sure. Somewhere, doesn't it say way up at the top here? That's what it looks like. This radio is sitting in my garage, I think. A23. Oh, come on. Higher up. There we are. So there we are. A23. RCA Victor A23. No question, I got the right thing here. So this is the wiring, and we want to look at the schematic. Now, first thing is, this is a much more complicated radio. I think it has more bands, maybe. It's got this whole push button set here. It's got a push-pull output with two 6K6s. I mean, this does not match. Does not match. Now, how's this going to help me? This is not going to help me, I don't think. Wow. Why did I even bring it up? I brought it up because things aren't matching in the other schematic, and I thought maybe this would help. But this is not going to look. This is not going to help. Push pull. It's got a phase inverter too. It's got all this stuff here, and a 6SQ7. I can't even remember why I brought this up. Just taking a look at it, my brain is frying here. Well, this isn't going to help. Let's put it away. Go back to this one here. See if I can remember what I'm doing. I can't even remember what I'm doing. No plate voltage. So what we want to do, I think, is explain that. Why is there no plate voltage on the plate here? So the plate is on this wire. This wire gets its voltage through this resistor. We must find this resistor, because from there it's kind of right on the high voltage bus. And we know everything. We know the detector is working here. But the audio I am pulling out right out of the detected audio. I'm not pulling it out of after the tryout here. Of course. Oh, wait a minute. What's this? Oh yeah, tone control phono socket. Right. Help me, man. I'm going down the drain here. Yeah, let me stop and just kind of calm my brain down a little bit. Too many balls juggling around, and it doesn't take many. Well, the question now is this the right schematic? Does it match the radio? What is going on here? Because I keep finding more things that don't seem to add up, and I'm having a lot of trouble sorting it out. So let's start right here at the top of the volume control, and I'm going to work my way up through this resistor, and we'll just do that. Let's do that. Okay, so top of the volume control. Let me see if I can get this camera a little bit closer. Okay, volume control. Volume control is here. This wire is the top of the volume control. It comes to this terminal. This terminal, we encounter two resistors. 22K going this way and a 2.2 megohm going that way. And if we look on the schematic, we see a 22K this way and a 2.2 that way. So no question, this is the point. This point should have this capacitor connected to it. Don't think it ever did, because here it is here. I've never done anything to it, and it's not connected here. It's connected to a point down here. That's just different. It's just different. The function of the switch is different. I think on the schematic it's a tone control. It could be, it's possible. You know, it doesn't make a lot of sense, because if you look on the schematic where they show the phono going in, it's unvolume controlled. It's on the far side of the volume control. This could be a killer, killing the output of the radio. But this is a small capacitor. But what's in the radio is a big one, not a small one. So what is going on? So if we look at how they've done the phono socket, it comes in through a 0.01. The phono socket used to come in through a 0.01. I can't remember for sure where it went. I think it went down here somewhere. I don't remember now. Oops. But that's completely different than the way this was originally wired, wasn't it? I thought it was. Okay, never mind that. Let's go up to this tube. So on this one, we find the plate here. This is pin number 1, 2, 3, 4, 5. Pin number 6. Plate connection, we should find this capacitor connected to the grid of the output tube. That makes perfect sense. And then along the way, some positive voltage right here. Plate voltage is stuck in, but this capacitor blocks the plate voltage from getting over here. It just goes to the plate here, supposedly. And that's exactly what we want to experiment with. So let's find the plate and follow this wire, see if we can find maybe this resistor, this capacitor, and see if this all makes sense. Pin number 6. So you might have to trust me a bit on this, because you can't see, but I can see. So I'm looking for the pin, the tube key. It's no question, it's right here. That makes this pin 1. Pin 1 is grounded down to the chassis. So 1, 2, 3, 4, 5. This is 6 back here. 6 has a capacitor coming across here. This black one here. A little hard to see again in the camera. And 6. It's a long stick here. 6. So 6 should make its way to this capacitor. So this capacitor down here is connected between 2 pins on this tube, which is a little bit confusing. In fact, one of the pins is spare. So they've used a spare pin here. This grid blocking capacitor connects to the spare pin, and then a wire leaves the spare pin and heads north up this way through the radio, almost certainly coming to the terminal we're looking at. Can we see that? Can I possibly see that? So it's this black wire. It's this black wire right here. You really can't see it. It's just under too many wires, and you got to be positive about these things. You can't. Close is not good enough in this kind of game. So I'm thinking it's coming from this terminal here to this terminal. There we are, 0. Okay, so that's fine. That's the plate circuit. And why am I concerned about it? Because I'm more concerned about what's going on up in here. So this all made sense. This guy makes sense. He's on the schematic. Everything makes sense. Why did I turn the camera on? I don't know. Just to reassure myself it's all making sense. Oh, because when I tested this, I couldn't find any B+. That's why. Okay, the B+, oh, the B, yeah. B+ not coming through here. The B+ is coming through a big resistor. Wasn't it this one? I can't remember. I have to look at the schematic. Why no B+ there? So what I wanted to prove was that this was the plate. Yes, that's definitely the plate. B+ there? You know, maybe I'm making a mistake, so I'm going to turn the radio on. It's okay. I'm going to measure with this meter for no particular reason. I don't doubt my other meter at all, but this guy's right here. Is there plate voltage? So first of all, voltage on the filter capacitor, 174. Got 100 volts on the radio itself. And on the plate, we see nothing. We see nothing. Let's just check some other. Am I wrong? I hit the wrong pin. I can't imagine it, but appears to be no plate voltage on the triode here. Plate voltage gets there. I don't know how. How does the plate? Oh, look at the schematic right on the screen here. Let me zoom in a bit. Plate voltage 6SQ7. Plate gets its voltage through this resistor R8. So we should find a resistor, big one, 470K off the plate. Okay, no, don't forget this is operating now. So off the plate down to what did I see there? Yeah, 470K, right. Ahead of the capacitor. So ahead of the capacitor. So oh. So maybe it's up in here. Maybe it's up in here, completely hidden from view. If I was a 470K resistor, where would I go? There's no sign of a resistor. Okay, any 470s in the area? That would be purple. 470 down here. Hey, that 470 is right on the right wire too. That's it. That's the guy. Yeah, and it's hooked up to a red terminal, so it's picking up the B plus and bringing it over. That all makes sense. So that guy could be open. Okay, so we're looking on both sides of him. Both sides of that guy. Okay, so I'm grounding my meter here. We're going down in here. Okay, this would be the supply side. There's no B plus on the output tube. Did I turn the radio on? Is it plugged in? Is it going? Is it going? I gotta put a light in. Oh, well, I'm sure it's going. Oh, I gotta see the tube element. Must see tube element. Oh. Yep, it's definitely going. Definitely on. Well, there's an easier way. Look for B plus on the on here again. So we got the B plus, although it looks a little low, but nothing down here. And either side, so this would be the other side here. Maybe it's here. I'm just doing it wrong. No, there's nothing there. Either side of this resistor? It can't be either side. This one here. There we are. So that's the input side. I was touching the wrong terminal till just now. So there's 171. And on the other side of the resistor, 0. That's an open resistor. It's an open resistor. You know, maybe the speaker's not dead. In the back of my mind the whole time I've been thinking, you know, you could just be totally wrong about everything you did. And the speaker's fine and there's other problems. Well, there's some other problems. There's no B plus on the plate of the detector tube triode. So radio cannot operate like this. Right, what am I doing? What am I doing? See, I'm getting all excited here. So we'll look for open circuit on the resistor. It's supposed to be a 470. Oops. Wasn't it a 470? It was a big one, wasn't it? 470K. 470K. And the set is off and the power's off, yes. Here we go. Well, that looks like an open resistor there. Ooh, what was that? Yeah, it's gotta be open. Okay, we found something. I'm gonna replace that resistor there. Okay, I think we're ready here. So what I've done is I've put a temporary capacitor back in to connect the volume control back up to the triode basically and send the audio signal back through the radio the way it's supposed to go and see if in fact it doesn't come out of the speaker, even though I seem to have proven the speaker's bad. Well, we might prove it's not bad, who knows. So volume down, set is on, voltmeters in hand. Scale set to 150 because we're looking for, it was 175, wasn't it? Well, that'll be okay, 150. We'll get a nice movement of the pointer. Here we go. That's my phone telling me it. That's my phone, yeah. That's my watch telling me I have to take it off and charge it. I hate to be critical of these things, but you know, this is crazy stuff. You have to charge it. So if you charge it overnight, you can't wear it overnight, and all these health things don't work because you're not wearing it. So you have to charge it during the day, which means during the day you can't wear your watch for half an hour, an hour. That's crazy. Yeah. Okay, what's happening here? So far nothing. Let's look for B plus. Okay, we'll put it on the 500. I will, and we will touch this. Did I not turn the set on? we're in big trouble now. What's happened? It's 100 volts on the plug. Did I not touch it? Maybe I didn't touch it. There we are. Okay, so it's only 150. Sounds like more is being drawn down. It's not very good either. Quickly, Jim. Moving quickly. Plate here. This is the plate. The plate has a little dribble of voltage on it. Wait a minute, this is a 500. Let's put it on the 150. Plate of the triode. Okay, so it's got 60 volts on it. That's close to what it's supposed to be. So now we'll go down to this capacitor. We'll go on the high side of it. Should see the same voltage. If I could just see the lead. Here, there it is. Same voltage, and on the other side we should see a 0. And see it go up a little bit there. Put this on the 15 volt scale, zero it out properly. Should see 0. But we're seeing 9 volts. It's positive. Not good. So, okay. The good thing is we got this, we found an open resistor. There isn't the slightest sound coming out of the speaker. Let me stick my ear up to it. It's just a hum. There's a hum coming out of it. So even though it has a field coil, there will be some residual magnetism left in the speaker, and that can be enough to make it operate a little bit. Did I say field coil? Output transformer. Yeah, what I just said didn't make sense. The field coil is operating, and that's probably why we can hear the speaker humming. What's happening is it's not getting a signal to the voice coil. Oh my gosh. Yeah. I think that's it for today. We solved one problem, but not another. Okay, so tomorrow, what time is it? Oh my gosh, are you kidding me? It's almost noon here. Yeah, I'm looking at my watch now. That's all my watch says. Get your battery charged. Yeah, let me leave it here. Tomorrow we'll do the experiment with the capacitors there and start replacing them. Okay, kind of a wild ride today, but good. It's good. Bit by bit.